All right, let's talk about a puzzle that sounds way harder than it is. The insolvable disks problem. But here's the thing. Is it actually unsolvable? Let's take a look.
So what if I told you that you can crack this tough-looking geometry problem with just one super simple trick?
Yeah, really. Let's get into it. Okay, the goal itself is pretty straightforward. Imagine you've got a bunch of points on a line. Your mission is to put a disk on each point. The catch? You've got to pick the perfect radius for each one so you get the most possible disks touching each other. But, and this is key, without any of them overlapping.
Now here's where things get a little tricky. See, if you make disk 1 touch disk 2, well, the size of disk 2 is suddenly locked in. And that decision then locks in the size of disk 3, which locks in disk 4. You get the picture. It's this huge domino effect, a massive chain reaction. And right here, this is the trap. If you try to actually calculate every single one of those radii, you're going to have a bad time. Seriously, it's a dead end. You'll just get lost in a mess of equations.
So, here's the big trick, the secret sauce. You've got to forget about the actual radii. We don't actually care how big they are. All we care about are the conditions, the rules that our very first disk has to follow to make sure the whole chain is even possible.
And boom, here it is, the aha moment. Every new disk in the chain puts a new rule on that starting radius. The even-numbered disks tell you your start radius has to be bigger than some value, that's our floor. And the odd-numbered disks tell you it has to be smaller than another value, that's our ceiling. We're literally just squeezing our answer into this tiny valid space.
Okay, so that leads to an obvious question, right? What happens when that space completely vanishes? You know, when the floor becomes higher than the ceiling.
Well, when that lower bound gets bigger than or equal to the upper bound.
That's it. The chain is impossible. It just breaks. There is no possible starting radius in the entire universe that can make that chain work.
But the solution for this is so simple, it's beautiful. You just let it go. You accept that you can't connect that one pair. So you skip it, and you just start a brand new chain right from there.
And just like that, poof! You've taken this super complicated, tangled-up geometry problem and turned it into a ridiculously simple solution. All you need is a single loop through the points. That's it.
And what's the ultimate payoff for all this clever thinking? A gorgeous, lightning-fast O of n solution, linear time. It is such a great trick for a problem that looks absolutely brutal at first glance. Definitely one to keep in your back pocket.